If you're anything like me, I'm sure you've been seeing a lot of crazy drama on YouTube lately, and today I want to take you out of the world of drama and show you an inside look of the fascinating world of traffic signals. So traffic lights are something we all love and hate. We love when they're green and we hate when they're red. But have you ever wondered how you get a green light at a traffic light? Well, let's go take a look inside of this traffic signal controller cabinet across the street, and I'll show you exactly how that works. So traffic intersections are built with an array of sensors. Here at this intersection, we are using Iteris vehicle cameras for vehicle detection. It's a sensor that's going to pick up your vehicle when you approach a stop bar at an intersection. And I'll show you how zones are drawn out and how you'll be more favorable to get a green light when you're sitting at a red light. So another set of sensors you may see at a traffic light are pedestrian push button devices. And these use a simple logic to communicate back to a traffic signal controller that will then give you a call and give you a walk symbol to cross a crosswalk at a traffic light. So the first thing you may ask is, how do we get power to all of these traffic lights at a traffic intersection? You see, these lights don't run off of hopes and dreams. We do have to get a permanent power solution from the power company. And right here we have a meter and a breaker combo on a power pedestal. You'll see this 50 amp breaker here. This supplies all the signal heads out in the field and also supplies power to this traffic signal controller cabinet. The other breakers in here will feed power to the luminaire lights that are on the tops of each of these shafts. And that photo cell is what controls those luminaire lights. When this does not read enough light, then you'll see if I cover it, you'll probably hear a contactor closing here, and you'll see out in the field that those luminaire lights have came on. So let's now open up this traffic signal controller cabinet here, and I'll show you some of the equipment that's used to keep you safe on your day-to-day commute. So right here is a traffic signal controller, and this is the brains of the intersection. This holds all the functionality of the traffic lights. It will accept inputs and then output to the field which lights need to be green, which lights need to be red, and even which ones need to be flashing yellow like that one over there. This controller also holds all the timing of the intersection. As you can see, if we go into the vehicle's times, each phase, and let's go over phases real quick. So as you can see, this through lane would be one phase and the left turn lane would be a separate phase. The through lane here would be phase 4, while the left turn lane here would be phase 7. So each approach and each different approach is going to be a different vehicle phase at a traffic light. So right here, if we have phase 4 and 7 inside the traffic signal controller cabinet, you can see on phase 4, for the minimum amount of time, they have 7 seconds, and the maximum amount of time that that traffic light can stay green is going to be 15 seconds. Same with 7, minimum time is going to be 5, maximum time is going to be 15 seconds. And as you can see, as vehicles approach the stop bar, it just cycled over to phase 4, which was giving them the green light on the through and right turn lane traffic here at this intersection. If you're enjoying this video, make sure to hit the like button and also make sure to subscribe. Let's get right back into it. You then also have pedestrian phases. So this crosswalk here is going to correspond with the through lane over across the street, which is phase 6, and this crosswalk now becomes phase 6 pedestrian. Meaning when you press this button, you get entered into a queue, and as long as phase 6 has a green light, when you press the button, you're going to get the crosswalk as long as you have no conflicting phases on this approach already. Now that you have the walk symbol, you are free to clear through the intersection and this crosswalk. Now that you have a quick understanding of vehicle and pedestrian phases, a little bit more of this stuff will start making more sense. So now on the bottom of the traffic signal controller cabinet, you can see where all the signal heads and the pedestrian heads are wired up. And we have it by phases. Phase 1, which is a green turn arrow, and then phase 2, which is going to be your typical 3-section head. Phase 2 is going to be the 3-section heads out there, while phase 1 or phase 5 specifically on this one, is going to be that flashing yellow arrow. We're using that as an overlap. So with phase 2, you also have phase 5, which is the green, and that's technically the phase. And then you have an overlap over here that's bundled up by a bunch of spider webs right now. But overlap C, which is landed on 15R, 15Y, and G, that is going to be the red, the solid yellow, and the flashing yellow arrow, which is technically a green. So as the signal controller and this cabinet, to its understanding, that flashing yellow arrow out there is going to be picked up and monitored as a green light. And this is what you can see on the MMU, these flashing Gs. That is the flashing yellow arrow at these traffic signals. So what we have here, we have the signal controller, which accepts all the inputs, predicts every movement out there. Once sensors, like these cameras here, and we're going to get more in depth into those here in a second, but once these sensors pick up and send an input into this controller is going to understand what it needs to output next and how much time it should output to a particular phase at any given time. So if you got vehicles stacked up on this through lane, it will give you the maximum amount of time and not just the minimum amount of time, allowing only one car out at a time. You will get a lot more time if you have multiple vehicles. So let's call this the brains of the intersection. Well, it's okay if you have a brain fart, but it's not okay for this to have a brain fart. So this needs to be monitored 24/7. And this MMU right here will monitor this controller and everything it outputs into the field at any given time. And if this has any kind of brain fart, this MMU will lock up the intersection, put it into flash, which will flip the switch here, and I'll show you an example. It's now flashing all red around this intersection. That's what this MMU is going to do if it sees any faults or failures on this controller or anything out in the field or anything internal inside of this signal controller cabinet. This is going to see that and lock up this intersection and make it go into flash. Let's take it back out of flash now. And right down here, we have a Polara CCU. This is going to be the processors for all of the push-to-talk pedestrian push buttons out in the field. And it wires up to this PLC board is where your push buttons go to, which then communicates over to the processor itself, which is hardwired into these pin connectors, and will put in simple calls and latch calls for pedestrians to get put into a queue and get served that walk indication. Now let's get into what everybody else is going to want to see, and this is going to be the Iteris CCU. This is going to be for all the vehicle detection and the cameras used at this intersection. So this camera has a Cat5 cable ran up and connected to it, and it runs all the way down this mast arm, down the shaft, and into this cabinet here, and gets wired up to this lightning arrestor and jumps over to this CCU. Once the camera is connected to the CCU, we can then go ahead and program the camera and set it up for presence vehicle detection. And as you can see, phase 4 and 7 that we have over here beside the traffic signal controller cabinet, you can see some zones drawn out on the through lane. So this is picking up phase 4. And as you can see on the left turn lane, we have some more zones drawn out, and that's going to be picking up phase 7. So as you pull up and approach this stop bar, that camera and these zones are going to detect the presence of your vehicle, which then is going to put in a hard call onto this controller, which will then allow the controller to know that you need to be served a green light. Also showing if you are not in these zones, meaning you are too far past the stop bar or way too far behind, then that camera will never see you, and then in turn will never serve you a green light. And these cameras work real well, and they'll even work for motorcycles. As you can see, as I'm just walking over into the approach here, I should be served the green light. And as you can see, these are going red, and I'm getting the green light over there. So these cameras do a wonderful job. Most people have issues with inductive loops when riding motorcycles or on a bicycle, where the inductive loop will not pick them up because they do not have enough metal. But when you have cameras at an intersection, they work just fine at serving you a green light, no matter the commute. And this CCU is set up for a TS1 system. So you see that we have some cards inside of this card rack, and this card rack is wired into these pin connectors through this backboard and also our detector panel over to the side. And whenever a sensor picks up the presence of a vehicle, the processor is going to communicate to the cards on the card rack. And as you can see, these lights dial on. It's going to then trip it and allow a call to be inputted onto the signal controller when a vehicle is present, or even advanced detection, where you can see further back that vehicle is approaching the intersection. You'll see that they'll start getting calls on the phase, and you'll see that it allows them to end up clearing through the intersection and not giving them a red light until they are fully through the intersection. As I really hope that I can pull you away from a little bit of this YouTube drama and show you the absolutely fascinating world of traffic signals and the entire traffic intersection system here, and all the magic that goes on inside of this traffic signal controller cabinet to make sure that you have a safe and efficient commute. If you enjoyed the video, make sure to like the video, and as always, thanks for watching. See y'all next time.